Hi everybody, welcome to today's lecture. I am feeling a little sick today, so I am staying home. I have bronchitis, so I'm hoping to be back at work tomorrow. I just have a bit of a sore throat, so thankfully nothing serious, and I hope to see you guys all on Friday. But this is just how things are happening right now, so I'm going to teach you guys today like I normally would, only this has been pre-recorded, obviously, and hopefully you get something out of it. I will go over it more in depth when I see you again, but for now I would really appreciate you focusing as well as you can to this video. I'm going to go over several examples with you of how to do this. It is a little bit more challenging than ionic bonding, which was really simple. That's what we did last class. And you guys are going to have a chance to practice. And from there, we will, you're going to upload some pictures on Canvas. There's going to be an assignment called Upload Your Covalent Bonding Drawings here. And after this lecture, you will have the wherewithal to be able to do that, hopefully. If you're, a little stuck or you're having a hard time, draw what you can and show me what you can do. And that will get you a long way. So I just want to see that there was some participation and some hard work while I was gone, okay? So let's get started. Today we're going to be practicing how to draw Lewis dot structures of covalent compounds. So recall that a covalent compound is between a nonmetal and another nonmetal, okay? And the reason why this is different from ionic formulas is that in an ionic formula, the metal transfers electrons to the nonmetal, okay? But here with covalent compounds, those are both going to be nonmetals and they're going to share their electrons. So how do you draw these compounds? Well, you need to keep a few things in mind. The first is that everybody wants to be satisfied. And in order for everybody to be satisfied, they need an octet around them. Okay? So what you guys are going to see these as is lone pairs, okay? Or you can see it as a bond. A bond is going to be represented as a single line. And a single bond represents 2 electrons. You're also going to see double bonds. Double bonds represent 4 electrons. And you're also going to see a triple bond, and a triple bond represents 6 electrons. Now, all of these are fueling the purpose that these atoms are striving for stability, and they want this octet, okay? So when you receive a compound and you're just like, okay, where do I start? What you have to do first is count up how many valence electrons exist in that structure, okay? So let's say I start with methane. Methane is CH4, okay? The formal name is carbon tetrahydride. So the first step you're going to do is add up the total valence electrons in the compound. So carbon is in group 4, so it has 4 valence electrons. And then you're going to add up hydrogen. Hydrogen is in group 1, so it has 1 valence electron. And look at that, I have 4 hydrogens. Okay, so this structure has a total of 8 electrons. Now, when I draw the structure, I cannot exceed 8 electrons. So I have to abide by how many electrons are in the structure, as well as making sure that everybody receives an octet. Okay? Now, there are some exceptions to the octet rule. One of them is hydrogen. Hydrogen doesn't need an octet. He needs what's called a duet. meaning he's perfectly content with 2 electrons. Hydrogen never needs any more than 2 electrons because if you recall, it only has an s orbital. It's 1s. Okay, so the maximum that you can fit in a 1s orbital is 2 electrons. So hydrogen never needs more than 2 electrons. Okay? So what you're going to do is you're going to decide who's going to be the central atom. Okay? The central atom is the guy that's going to be closest to francium and furthest from fluorine on the periodic table. Okay, and this has everything to do with electronegativity. Okay, now you might remember from our periodic trends unit, this was a rather short unit, but in the periodic trends unit we discussed that fluorine is the most electronegative atom, meaning it is able to attract electrons. Okay, now what you want to do when you're drawing these is put the guy that is the least attractive towards electrons in the center, okay? So another rule is that hydrogen is never the central atom because hydrogen can only carry 2 electrons. It only has that capacity. The one who's going to be the central atom is going to be able to latch on to a lot of different things. And guess what? A lot of the times that's going to be carbon. Okay, carbon is a very good central atom. It's the basis of organic chemistry. It's all of living compounds. Sulfur is a very good central atom. Phosphorus is a good central atom. So there's a lot of good central atoms that things can bind to, okay? But again, your central atom is the guy that's going to be closest to francium and the furthest from fluorine when you're trying to determine who it is, okay? Then what you're going to do is bond the atoms around the central atom with a single line. Okay, that's the first thing you're going to do. So here I have carbon tetrahydride. So carbon is going to be my central atom. And now I need to bind 4 hydrogens to this carbon. So I'm going to go ahead and bind 4 hydrogens. 1, 2, 3, 4. Okay, and just like that, I have my structure. Now I need to count and make sure that it abides by this number of electrons that it says it should have. Okay, so remember I told you guys before, 2 dots represents 2 electrons. 1 line, a single line represents 2 electrons. So a single bond does represent 2 electrons. So here I have 2, 4, 6, 8. Okay. So around carbon has this octet, 2, 4, 6, 8. It has 8 electrons around it, and that is represented by these 4 single bonds. Okay? Also, hydrogen only wanted a duet. It only can sustain 2 electrons. So that's represented here by these bonds. Okay, so hydrogen is happy and the carbon is happy. And they're abiding by how many electrons they should have. So therefore, you are done drawing the structure. This is your structure. Carbon tetrahydride will look like this, okay? Again, to check your work, you want to make sure that all of the atoms are happy. Okay, they all have what they want. Carbon wants an octet. We have that, 2, 4, 6, 8 with the single bonds around it. Okay, hydrogen wants a duet. It only wants 2 electrons. We have that represented by each single bond. So there you go. You have your structure. So this would be methane. Doing another one. This is, I'm following in your Nearpod, by the way. So I'm just going through all the examples in your Nearpod. The next example is carbon tetrachloride. This one's a little bit different. So carbon tetrachloride. Carbon is in group 4, so it has 4 valence electrons. You're going to add up. Chlorine is in group 7, so it has 7 valence electrons, and I have 4 chlorines. So now we're going to add them up to determine how many electrons are in our overall structure. So 7 times 4 is 28, plus 4 is 32 electrons. Okay, so my structure needs to end up having 32 electrons. I have to abide by the octet. Okay, everybody wants 8 electrons around them. Okay, so we're going to start with who is going to be our central atom. In this case, we have carbon and 4 chlorines. Okay, chlorine is really close to fluorine. It's in the same family. And carbon is a very good central atom. And in fact, if you see these 4 chlorines, you know that they're going to bind to this carbon. So going ahead, I'm going to put carbon as the central atom. And then I'm going to surround it by a single bond with these 4 chlorines. So I'm going to draw 4 chlorines around the carbon. And keep in mind that every single bond represents 2 electrons. So right now around carbon, I do have an octet. I have 2, 4, 6, 8. Okay, this represents an octet. Each single bond represents 2 electrons. So carbon is happy right now. Okay, but keep in mind I need 32 electrons. So what you're going to do is fill up the chlorines with their octet, okay? So here I have, let me do this pen here. Here I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Okay, and just like that, I have abided by my 32 electrons that should be in this structure. And in looking at each atom, carbon has an octet, chlorine has an octet, this chlorine has an octet, 2, 4, 6, 8. Okay, everybody has an octet. So we are sitting really pretty right now. Okay, so the examples that I've done so far have all been single bonds, okay? I'm going to teach you guys double bonds and triple bonds when I get back, but I am going to do a few more examples with single bonds, okay? So again, this is carbon tetrahydride, or tetrachloride rather, okay? So keep in mind my method here. We count the number of valence electrons, you have to add them up. Then you have to make your structure. Carbon is going to be in the central atom, and chlorine will be surrounding it. The next example from your Nearpod is water. So we're going to do water right now. So water, better known as dihydrogen monoxide. Remember, in covalent bonds, we're sharing electrons. That's why I'm not drawing any arrows like you guys saw with ionic. Okay? So water has 2 hydrogens. Hydrogen has 1 valence electron, and we have 2 hydrogens. And we have an oxygen. Oxygen has 6 valence electrons. So my total electrons for this structure is 8 electrons. Okay? I need to have 8 electrons in the structure of water to make it chemically sound, okay? So now you want to figure out who is the central atom, okay? Who is going to go in the middle, okay? Well, we know that hydrogen can never be a central atom because it can only sustain 2 electrons, meaning it can only sustain a duet, okay? Oxygen, on the other hand, can sustain an octet, so it will be able to bind to different things. So with that, I'm going to put oxygen in the center, And then I'm going to bind 2 hydrogens as the formula calls for, okay? The formula tells you guys what you need. If it's H2O, that means you have 2 hydrogens and 1 oxygen. So you need to draw that in your structure, okay? So I have my oxygen in the center. Then I'm going to draw my 2 hydrogens, okay? And now I need to make sure everybody is happy, meaning they have an octet or a duet, whatever they call for. And I need to make sure that I abide by this notion that this compound should have 8 electrons based on the valence electron number. So I'm going to look at this hydrogen. This hydrogen looks happy. He has a single bond, so all he can sustain is 2 electrons, so we're good. This hydrogen on the right is also good, but this oxygen here in the center is missing two lone pairs. So we're going to add those, okay? So now I have 2, 4, 6, 8, okay? So now my structure has 8 total electrons, okay? I have 2, 4, 6, 8. And that's how many I should have here, okay? So this is all because in covalent bonds, we share electrons, okay? So it's not this matter of transferring like you saw in ionic, but we are actually sharing electrons, okay? So this is what water ends up looking like, okay? So it has 2 lone pairs on the central atom and 2 single bonds going to the hydrogens. The last one I'm going to do is one involving a double bond, and that's going to be with oxygen, okay? So let's say I have O2, okay? Oxygen is in group 6, so it has 6 valence electrons, and we have 2 of those. So we're looking at 12 valence electrons in the structure. So that means my final compound has to have 12 valence electrons. Since the compound is O2, I'm going to draw 2 oxygens, okay? And then I'm going to start filling up the octet, okay? So I have both of these oxygens need an octet, and I need to fill in for those 12 electrons that the structure calls for. So this this single bond here is 2, and then we have 4, 6, 8, 10, 12, okay? So right now we've run into our first problem. This oxygen here doesn't have an octet. It has 2, 4, 6. It does not have 8. On the contrary, this oxygen on the right does have 8. It has 2, 4, 6, 8. Okay? So this oxygen here on the right is happy, but this oxygen here on the left is missing a lone pair, and therefore it will become unstable. So to fix this problem, what we're going to do is we're going to borrow a lone pair from the guy who's happy, and we're going to make another bond, and that's going to help us produce a double bond. Okay, so what I'm going to do is I'm going to take the guy who's electron rich, which is the oxygen on the right. So I'm just going to erase this lone pair here on the bottom. And then what's going to happen is I'm going to make a double bond. And the reason we're going to make a double bond is because a double bond represents 4 electrons, okay? And remember, we are sharing with covalent. We share electrons with covalent, okay? So now I want to go back and I want to check, is this oxygen happy? So I have 2, 4, 6, 8, 10, 12, okay? So just like that, I have abided by the 12 electrons that should be in this structure and making sure everybody has an octet and they're therefore happy. Okay, so that's where double bonds and triple bonds come into play. I hope this was a good introduction for you. What I'd like for you guys to do now is in your module, I'd like for you to click on the assignment that says upload covalent bond drawings here. That's in module 6. And I want you guys to practice drawing those compounds in that assignment, okay? Be sure to upload them. You can use a sheet of paper and take a picture of it, or you can use Google Keep, okay? Whatever the outlet that you use, make sure to upload it. I appreciate your patience, and I hope to see you very soon.